In this video, I'm going to walk you through a typical Oxbridge economics interview question to kind of help you think about what the questions will be and how you should go about answering them. So a lot of the time in the Oxbridge economics interviews, they tend to ask a game theory question. I'm going to take the chance to walk you through a particular game theory question, which is similar to ones they could ask in interviews. This question is quite long and detailed, but don't worry, I'll put a picture of the question on the screen. So this is the basic premise for how the game works. So imagine there are 5 pirates and they've come across some treasure. And let's say, for simplicity's sake, that this treasure is 100 gold coins. The pirates are a logical group, and they've thought of a way in the past to figure out how they split up such treasure. So the way the 5 pirates go about splitting up treasure is they have a system based on age. So we'll say that pirate 1 is the oldest, pirate 2 is the second oldest, and so on and so forth, and thus pirate 5 is the youngest. And this is the system they have for splitting up the gold coins. So the oldest pirate, so pirate 1, gives a proposal to the rest of the pirates. For example, pirate 1 may say, I get 50 gold coins, pirate 2 gets 20, pirate 3 gets 10, pirate 4 gets 10, and pirate 5 gets 10. So he proposes some way to split up these 100 gold coins. All of the pirates, including the one that has made the proposal, then vote on this proposal. The way it works is if it gets a majority, they go through with the proposal, otherwise they don't. In the case of a tie, the person who made the proposal, the proposer, has the deciding vote. So like I said, if the pirates agree, if there's a majority, then the split happens. If this isn't the case though, the pirate that has just made the proposal gets thrown overboard, and it's the same system now, but only down to 4 pirates. So now the second oldest would make their proposal, and again we'd have this voting system going on. And essentially this process is repeated until the proposal is accepted. And we assume that pirates first and foremost care about surviving, about living, and then they care about gold. And their utility, their happiness, is directly linked to the amount of gold they get. So for example, getting 100 pieces of gold is always better than 99, which is always better than 98, etc. And now the question is, how does this game play out? Now I get that this is quite a complex game we're looking at right now, but the best way to go about it is to think about it in the simplest form and then build up from there. The way not to go about it straight away is trying to think what the oldest pirate, pirate 1, will do straight away. Because we've got so many different things that are going on, so many different ways to think about it, it's hard to really know what to do. It kind of makes a bit of intuitive sense to think, well, pirate 1 doesn't want to die, so he's going to basically take nothing for himself and just try and give it all away to prevent himself from dying. But as you'll come on to see, that's actually not what happens. So the way I'd recommend going about this is trying to think about the last case and build up from that point. Kind of like a bit of backward induction. Okay, so let's think about the game at hand. So we've got 5 pirates to begin with, but let's think about a situation where it got down to just say the last 2 pirates. So this is pirate number 4 and pirate number 5. Now they've got the 100 coins, and pirate 4, being the older one, gets to make the proposal. So I have to think, what will pirate 4 do in this case to make a proposal where he gets as much money as possible and also, well, doesn't die? Well, if you remember, the person that makes the proposal gets the deciding vote in the case of a tie. As there's only 2 people, unless they both vote for something or both not vote for something, it will be a tie where 4 gets the deciding vote. Therefore, pirate number 4 can give himself 100 of the gold coins and make the proposal that 5 gets none. Knowing number 5 will say, no, I don't want that, but number 4 will say, well, I do want that. And because number 4 gets the deciding vote, this will go through and number 4 will get all the gold coins. So now we know that that's true, and that's the case. We have to know that number 5 really does not want to get to a situation where it's just number 4 and number 5 left. I.e. all the other 3 pirates have been thrown overboard, and it's just these 2 left to go about the proposal, because number 5 knows that he'll get nothing if that's the case. Therefore, if number 3 is a rational being, which let's just say he is, he knows that number 5 will accept 1 gold coin in number 3's proposal and say yes to that, in order to not get to this situation where it's just these 2 left and number 5 gets nothing. Okay, so then number 3, if it's number 3, number 4 and number 5 left, could make a proposal where number 4 gets nothing, number 5 gets 1 gold coin, and number 3 gets 99 gold coins. Okay, number 4 obviously is going to vote no to this proposal. Number 4 wants to get to a point where it's just him and number 5, as that way he can get 100 gold coins. But number 5 will vote yes to this proposal, because he knows if he votes no, he's going to get to this situation where he gets nothing. So therefore, if it gets to a situation where there's just 3 pirates left, the third oldest, the fourth oldest, and the fifth oldest, or the youngest as you'd like to say. This will be the proposal that number 3 makes, and that will be accepted, as number 3 will accept, number 4 will not, but number 5 will also accept, hence as a majority. But number 4 now knows that this is the case. So if number 4 now knows that this is the case, he can use this information to influence the proposal that he makes. I'm saying number 4 knows this is the case, I mean number 2 knows this is the case, apologies. So now we have, let's say, 4 pirates left. We've got pirate number 2, pirate number 3, pirate number 4, and pirate number 5. Now remember before, we know if it gets down to the last 3, pirate number 3 will make this proposal of 99, 0, and 1, and it will be accepted. And pirate number 4 knows that if it gets down to these 3, he's going to get nothing. And therefore, pirate number 4 will accept a gold coin payment of anything greater than 0 to avoid getting to the state where he'll get nothing. Okay? So therefore, number 2 here could make the proposal that he gets 99, number 3 gets nothing, number 4 gets 1, and number 5 gets nothing. Because, well, number 2 obviously is going to vote yes for this. Number 3 is not going to vote yes, obviously, because he wants to get down to the point where it's just these 3 left, and therefore he can get 99 by doing the proposal we just talked about before. Number 4 will say yes, because he prefers 1 gold coin to 0 gold coins, and number 5 will say no. Okay? Because he knows if he gets down to 3 of them, he'll get 1 gold coin, which is better than the 0 gold coins. But because it's even split, but number 2, the proposer gets the deciding vote, therefore we'll get this situation here. Okay? But number 1 now knows this will happen. So what number 1 can do is use this information to impact the first proposal, this is the oldest pirate, number 1, that he makes in the first place. Okay? So now let's go back to the situation we have at the very start, where we have 5 pirates. Okay? So what can number 1 do here? Well, he could give himself 98 gold coins, giving number 2 nothing, give number 3 1 gold coin, give number 4 nothing, and give number 5 1 gold coin. Knowing that, well, he'll say yes to this. Number 2 will say no, because number 2 wants to get to this situation where they can get 99. Number 3 will say yes, because this situation getting 1 gold coin is better than the situation that would happen if he voted no, which is he'd get no gold coins. Number 4 will say no, because he prefers this 1 gold coin to these no gold coins. And number 5 will say yes for the reason that he prefers 1 gold coin to 0 gold coins. And hence we have a majority. 3 people voted yes, 2 people voted no, and therefore we'd expect this to be the system. We expect number 1 to make this proposal, and these people to vote in the order I've done here, with the ticks and crosses. Okay, and that would be a very good, succinct, well-explained answer to this particular question if you were faced with it at interview. Now obviously the question I just discussed and the solution or answer relies on a lot of assumptions which you could talk about and that your interviewers will probably bring up in your interview. The main one being this sense of uber rationality, where all these pirates are thinking ahead of all the possible solutions and thus using that to inform their voting decisions. In reality, we could argue, would this happen? And the chances are probably not. You know, when we run experiments, when economists run experiments and they do these games, they don't really necessarily see the expected results being parallel with the actual results they get from the experiment. And that is mainly because of this thing of uber rationality and the fact that maybe doesn't really exist in reality. So you could very validly question the notion of, would this actually happen? Would number 1 pirate make that proposal, and would the voting that we predicted happen actually happen in reality? Maybe not. But that's the sort of way they like you going about these questions. Thinking about it very logically, very numerically, and thus deriving your answer from that. And there it is. That is a walkthrough of what you might expect from an Oxbridge economic interview question. If you have any questions or queries, please leave a comment down below. Thank you very much for watching, and I'll see you soon.